Okay, well, it is one past the top of the hour, and we still have people signing in, but we're just going to get started. Uh, Firstly, welcome. Thank you for joining us. This is the Machine Metrics webinar series. For this episode, we're taking on machine data and the digital thread. So a little backstory here. As many of you are aware, manufacturing still remains the largest industry in the world with perhaps the least digitization. This lack of data leads to massive inefficiencies that affect every component of the manufacturing lifecycle. However, it is estimated that 60% of global manufacturing companies will begin to use and leverage connectivity and connected devices for analysis in the coming year, which is really evidence that IoT is already driving unprecedented disruption in a frankly notoriously slow adoption industry for technology. This access to data will transform traditional manufacturing operations and supply chains into dynamic, sustainable, more resilient, interconnected systems. The value of data cannot be understated during this time that we're all experiencing. We have on our hands a whole new arsenal of data to drive decisions with. And in a increasingly complex manufacturing environment, manufacturers are looking for any edge they can get to remain competitive in a heavily globalized economy. So how will this potential be unlocked? Enter the digital thread, the buzzword rocking our manufacturing world. But what is the digital thread, right? How does a manufacturer enable the digital thread? And frankly, what does it have to do with us? These are the questions that we are here to answer. My name is Graham Immerman, and I am your host and moderator. I have a bit of a treat for you all today because today's presenter is none other than our co-founder and CEO, Bill Byther. So we're really excited to have him giving this presentation today. I'm just going to do a quick review of our agenda. We're going to do a brief introduction from Bill, who's going to give our presentation. We are going to have a Q&A at the end of this session, and we're going to talk a little bit about what's coming next. But before we get started, just a couple notes. Firstly, this webinar is being recorded. Fear not. We will send out a link to the recording after the webinar. We also highly encourage questions. There is a Q&A within the Zoom navigation, and you're able to ask a question at any time. Please do not hold back. If we cannot answer that question in real time, we will answer it during the Q&A following the presentation. Well, enough about me. I'd love to move on to Bill's presentation. So I'm going to stop my share and I'm going to allow Bill to take over and take the reins. Bill?
Great, thank you, Graham. So today, as Graham said, I'll be talking about the digital thread. Thanks for joining us this afternoon if you're on the East Coast like me, or perhaps good morning for those in Central and West and outside. So my name is Bill Byther. I'm the co-founder and CEO of Machine Metrics. And my team and I are based outside of Boston, Massachusetts. We came together back in 2015 to transform manufacturing. So there's been a lot of buzz associated with Industry 4.0 and industrial IoT, words that we hear of all the time. One that I believe is really crucial for the success of automation in digital factory is what's called the digital thread. So over the next few minutes, I'll be explaining what the digital thread is, why it's important, and how you can implement it. So the promise of industrial IoT is to connect your equipment and use data to drive efficiency. The reality is that most implementations fail, 76% according to Cisco. This is just a couple of years ago. Equipment in manufacturing is diverse and difficult to connect. Some have connected their machines only to find that their data is not actionable. Existing IoT platforms are not specialized. They do not have the operational data required to make the best decisions. Those that have been successful have required outside integrators, professional services, and years of custom development and continued maintenance. We know that in order for the digital factory to reach scale, this needs to be easier, and it's really why we built Machine Metrics, but more on that later. So first, what is the digital thread? Some of you have heard of it, some haven't, but it is a term that's kind of spreading across the industry. So both the digital thread and digital twin came out of aerospace manufacturing. Coincidentally, it's actually where I started my career. And the digital thread essentially seeks to create simple and universal access to data during the entire value chain of the product lifecycle. The term is just starting to be used outside of the context of manufacturing, but for the purpose of this presentation, we'll keep it to manufacturing. The digital thread essentially feeds data into the digital twin, which is also used commonly. And the digital twin is basically a digital replica of the physical asset, but you need that digital thread in order to enable this digital twin. So for discrete manufacturing, the digital thread starts with product design, in which includes engineering of the part and assembly. It's then passed on to the manufacturing process, which is required to make the part, instruct people, service equipment, and finally, the digital thread extends to the supply chain and customers, where the manufactured part finally enters service. So, why the digital thread? Even in this digital age, systems are mostly black boxes with little data flowing from one system to another. Having access to data through every step of the life cycle allows for increased speed and decision making. The ability to optimize each step of the product life cycle is much greater by closing the loop with actual data. Imagine a world where data flows back and forth in real time through every step of the process. So getting back to the product life cycle of a part, each step in the process is essentially a black box. Like I said before, the first requirements are gathered, the part is designed and prototyped. This part is then passed on to manufacturing, where the part is being produced. While today there's communication between manufacturing and engineering, it's not systematic, it's not real time, it's not agile. When a design problem appears in manufacturing, it's passed back to engineering and essentially passed over the wall for a redesign. The process repeats itself through every stage of the product lifecycle, through design, through manufacturing, through the usage of the product, and finally servicing that product. This process takes many months, even years. A good example of this is how I started my career 25 years ago as an engineer on a Joint Strike Fighter. This is years after the initial concept, which began in 1993, and only last year did the Navy version of now the F-35 finally enter service. From concept to production, this process took 26 years. I would say that this is sort of the extreme end of that process. There's many parts being designed that that might take months, or certainly less than 26 years. But this the digital thread can really accelerate that process and enable better design, better efficiency. So the product. Let's start with product design, sort of the beginning of the life cycle. Every step of the process requires software systems, such as CAD, CAM, requirements management. We talked briefly about the concept of a digital twin, which is new, but these software systems now go much deeper than they ever did before. So if we go to manufacturing, there's systems around monitoring your asset, instructions. How do you inform the the operators to set up or change over their parts. Quality, it's a really important part of the process of manufacturing. Inspecting those parts, ensuring good quality. Logistics, controlling the ordering of materials. All of these require systems. These systems are mostly black boxes. They don't communicate with one another. So we get into actually deploying this product. It's being used. You're using systems like CRM, traceability. If there's a quality issue, a failure, you want to trace that back to the manufacturing process. And these are systems that are used today, but again, there's very little data flowing between them. If you get into servicing the equipment, How do you support the product as it's deployed? There's help desk software that's often part of your CRM. Maintenance management system, CMMS, that you can schedule repair time, and these systems often don't even look at the usage of the equipment or the various alarms and predictability that you actually see in failure of these machines. And then spare parts. Imagine your service person comes to manage or to fix your equipment, and they find out that there's something wrong with the machine. There's a bearing that failed, and that it does not. They don't have access to those parts in their on site in their van. If you had that data ahead of time, you would know to stock your vehicle with the right parts. So essentially the goal is to connect to each step of the manufacturing process with a continuous flow of data so better decisions can be made quickly. Intelligence is built into the systems used for each process so that the changes are fluid. If you look at parametric design, this was established in the 90s of 3D CAD. Changing one dimension in a model propagates through the entire 3D model as the design requirements are factored into that design, not just the dimensions. So a similar concept can be applied to the entire manufacturing process. And this is essentially the digital thread. Each step of the product lifecycle is continuously optimized based on data from other steps in the process. This really closes that loop in the product lifecycle. So in manufacturing, there is essentially an ecosystem of systems that, as I said before, they don't really communicate with one another today. Most of these systems are on-premise. Data is stored in proprietary databases, and it's difficult to get data out of these systems without a team of experts and professional services that have experience with each of the individual systems. The digital thread requires easier access to this data and in real time. So in order to close the loop with data, each of these systems used in each step of the process needs to be connected. This can be accomplished through open APIs and easy access to data. A well-designed cloud application makes data sharing much easier, and integrations can be built much faster. Industries such as fintech, healthcare, and logistics have been able to digitize faster by leveraging the cloud. And an ecosystem of connected software as a service applications, otherwise known as SaaS, is starting to really to build up. While manufacturing has been slower to adopt these technologies, it is now happening, and you're starting to see these systems modernizing. They're cloud-based, and they have access to open APIs. So let's take this over to what's really relevant to machine metrics, which is machine data. So machine data carries a lot of weight in the digital thread. It applies to all aspects of the product lifecycle. The digital factory requires machines for automation, and machines produce a lot of data. Machine data is critically important to drive efficiency in the manufacturing process, knowing when to service equipment, alerting operators to add material, enabling automation through robotics. This all requires access to this machine data. The digital thread extends well beyond the manufacturing process, though, and that's what this diagram really represents. So, if you take a look at ERP systems, once they have access to real-time production data, suppliers and customers will have a better knowledge of when parts will be delivered, and quoting can be more accurate. In a design process, knowing the actual limits of the machining process and where on a tool for machine data can be used to optimize assumptions made when CAM software generates these toolpaths. Knowing when a machine requires maintenance can trigger spare parts delivery from the machine service provider. The maintenance technician can arrive on site with the right parts to make a repair. Quality issues in the field can be traced back to the exact point of time and data that was used to make that faulty part. So that change can be made to prevent this failure from happening again in the future. So due to the complexity and variety of equipment on the factory floor, it's been particularly difficult to access this data in a way where analytics can be run, let alone making it available for the digital thread. So as you might have figured out by now, this is why we built Machine Metrics, which is manufacturing's industrial IoT platform for machines. We've made it very easy to capture and transform data from machines, and then make that data actionable through increased visibility, predictive analytics, and configurable workflows that automates the operation of the machine. This data is then made accessible via open APIs, and this helps feed data into other factory systems. We are essentially building the operating system of the automated factory. So Over the past 5 years, we've connected to thousands of machines across hundreds of customers worldwide, mostly in discrete manufacturing industries, such as medical device, automotive, aerospace and defense, oil and gas, and heavy industry. I'm going to essentially give you just a brief overview of how this all works. As we know, getting access to that machine data is an important component of this digital thread. It really starts with the edge platform. Our edge platform can be used to easily connect to any machine. Essentially, data is collected directly from the machine's control for modern equipment, or sensors can be added to legacy equipment. We automatically transform this machine data into standard data structures using our AI-driven transformation engine, so that this data can be scaled across many machines of different types. Data can be collected at high frequencies, and this allows data scientists to develop custom predictive algorithms that can be deployed to the edge and managed at scale. So once the data is transformed from the edge, it's streamed to the Machine Metrics IoT cloud infrastructure. This infrastructure is designed specifically for machines and the high volume of diagnostic and sensor data that's associated with machines. Operational data is layered on top of the machine data to add additional context. So not only do we know the machine conditions, but if the machine isn't set up, down for maintenance, and the part numbers that are being produced. It's the patterns in this data that generates insights, that initiates actions through no-code configurable workflow triggers that we make available right out of the box in our application. These triggers can send notifications or initiate entirely new processes. Some of those processes are built into machine metrics to optimize the operation of the machine, or they can be external processes. So it's the built-in applications that drive value immediately after connecting equipment. An example of these applications include an operator interface to solicit feedback from operators, or configurable reports that can report on OEE or downtime. But then custom factory applications and integrations into other factory systems can be built by not only ourselves, but our customers and our partners. And this provides additional value on top of just the machine data and really contributes to the digital thread. These applications that are built can be hosted by Machine Metrics. We've built out this application platform that allows software developers to very rapidly build these applications, web-based applications. And then they don't have to worry about where to host these applications. We can actually host them right for our customers. Essentially, we're building an ecosystem of software developers that are passionate about solving manufacturing problems with data. And this access to data will accelerate the digital thread. So having out-of-the-box value is critical for adoption, and really the first step before being able to contribute to the digital thread. We allow our customers to be more efficient through analytics and bringing them through what we call the manufacturing analytics journey. I know there's been previous presentations that I've given just on this journey and all the use cases that we're able to solve right out of the box, beginning from descriptive analytics all the way through predictive and prescriptive. So starting with descriptive analytics, customizable dashboards, historical reports, and alerting will improve production visibility. And then the action associated with that, being able to notify the right person at the right time when production falls behind. This is all really important and provides that initial value with the machine data. So diagnostic analytics provides a deep understanding of why past events have occurred. These events can be visualized in our timeline. We have a diagnostic timeline, and this will help determine root causes of issues. So predictive analytics has been really elusive in discrete manufacturing due to all the varied machine manufacturing processes. However, we've developed our own predictive algorithms that can be applied to many of our customers, such as detecting tool wear and tool failure. But we also make this data available to data scientists who can build their own predictive algorithms to detect issues, quality issues and unplanned downtime. And then finally, it's the prescriptive applications that really inform the user on what steps to take to avoid problems from occurring to begin with. Often for many of these use cases, this requires a collaboration with multiple sources of data, again, the digital thread. And these integrations into third parties, such as work instructions and maintenance applications, is an example of how we enable prescriptive applications that are driven by machine data. So the value we provide directly around improving the efficiency of the machining process and enabling the hundreds of customers to drive efficiency is really that out of the box value. But we're now developing an ecosystem of partners and developers that are building applications on top of our platform. This extends beyond just the machine data, and Machine Metrics is positioned really uniquely to to provide that data to the entire digital thread. We're really just at the beginning. We're just getting started to fulfill our vision of being the operating system for the automated factory. And this really is kind of where we are in contributing to the digital thread. I really thank you for your time. I know this was a short presentation, but I want to make sure that that you really were able to see through the full product lifecycle how it is that the digital thread can really help you, and how Machine Metrics, by giving you that easy access to data, can really enable your company to really get started in the digital thread. So thank you for your time, and I'll open it up at this point to any questions.
Yeah, that was awesome, Bill. Thanks so much for the great presentation. If you wouldn't mind popping back to that last slide, maybe we'll leave it there to, because for me, as I look at it, it provides a lot of questions for me too. We've got a number of questions coming in, so I'm just gonna take them as they come. Again, if you do have any questions, feel free to drop them into the Q&A section of the Zoom, and we will take them, as many as we can during the period of time that we have. The first question, and Bill, I know that you covered this a little bit, but maybe you could just clarify again for our listeners. Could you explain the difference between the digital thread and the digital twin?
Sure. So, well, first, I would say that this concept really started, this is in my own research, in 2002. And starting with the digital twin. So a digital twin is essentially a digital representation of a physical asset. You might think of it as a 3D model, right? A 3D model provides the sort of the physical twin to the actual physical asset, or the dimensional, the 3D space. But there's more to it than just the the features. It's how that product actually behaves, how it moves, what happens when loads are applied, and that's really the digital twin is really taking all of the physics that occur in the real world and simulating that digitally in a digital twin. And that's not actually something that Machine Metrics provides. We provide the data to help enable technologies like the digital twin. But what the digital thread is really all the different systems that really feed into that, so that the digital twin essentially has that information in real time. And all of the context and the learnings that come as a result of all the different processes that occur during the product lifecycle and the usage of that product.
Awesome. Thanks for clarifying that. And there's a question that just came in about Machine Metrics. Could you just clarify how Machine Metrics connects to manufacturing assets?
Yeah. So I showed in the slide on the edge that we actually most often will connect to equipment right through the machine's PLC or control. We're able to also connect to older equipment or legacy equipment using sensors, or a combination of both. And we've built many connectors in Machine Metrics so that the connectivity is very plug and play. Most of our customers will install Machine Metrics themselves. We do that so we can scale. We don't have to send people on site. And this has enabled rapid adoption of Machine Metrics across our customers, and the ability to scale this up across many hundreds of machines, many plants. And it really starts on just that sort of that ease of connectivity, and the ability to transform that data into a data structure that you can actually run analytics, that you can have multiple machines of different types that all essentially speak the same language.
Okay, great. This is a good one, and we've got a couple questions around this. I'll just read it verbatim. I was wondering whether there's a good starting point would be in terms of improving analytics when looking at the product lifecycle. Is it always design, or would you recommend somewhere else, like starting within the manufacturing phase?
Oh, well, I mean, I can tell you that we live more in the manufacturing side. So, I have, I guess I'm a bit biased, but I think there's an opportunity for analytics across the whole life cycle. But when it comes to manufacturing, this is when you're running systems, continuous systems to actually make parts, and you have production goals, and this is often not visible. And some of the very basic use cases and value that we see is just simply providing this visibility in real time on the factory floor. So if you're asking like where do you start, if you go back to that analytics journey, it's really in the visibility of data. That can provide a lot of value right out of the box. It's simple, and often many manufacturers don't even have the basic visibility.
Yep. Okay, thanks. Yeah, that's great. And this is a good one because this is something we were debating last night a little bit. Is the digital thread really just an advanced data integration exercise, or is it something more?
Well, I mean, certainly you need to have the systems communicating, to really leverage the digital thread. But if all you have is the the connections, that doesn't give you all the context. You still need a layer on top of that to take action. So a maintenance system connected to the machine data will needs to understand when a part is going to fail, so that it can predict what spare parts are needed. So you need to have that additional intelligence that's sort of built by having these systems connected. And often these are this is knowledge that's very domain specific. So it might be that only your facility has the information required to take it to that final step, and that would be the you want to leverage all these out of the box applications and systems to get you as far as you can, and you take it to that last step by providing your own knowledge on top of the manufacturing or design process.
Awesome. Okay, two very different questions here. The first one, do you have any specific examples of how machine metrics and machine metrics customers are leveraging the digital thread into other factory systems today? Yeah,
we have integrations into a number of systems today. Different ERP, MES systems. So an example there would be typically an operator would have to manually type into the ERP at the end of every shift how many parts are produced, and we're able to systematize that and automate that. The other is around understanding your standard cycle times. What we see quite often is that we design a part, you have a cycle time, say it's 10 minutes. Once you actually start making that part and programs are tweaked, it might actually take longer to run that part. And that's not often, that's when I talk about closing the loop, that loop is often not closed. There's other systems like I mentioned before, like we've tied into some quality systems, some maintenance CMMS systems that help automate maintenance. And I'll honestly tell you that we're just at the start here. It's easier for us to integrate with other cloud-based systems that have open APIs. Those are the ones that we're really starting with. But then there's also legacy systems that just require more work, more integration. It's not impossible to connect those systems, but they take longer to actually bring into production.
Bill, if I can push down that road a little bit more for our listeners. So you're talking about expected cycle times, right? Real-time machine data, right? And, talking about how that may impact, scheduling, for example, right? So is what you're saying that the machine data digital thread is where you take that data that we're collecting in real time and leverage it to make real-time augmentations to, say, like a shipping schedule, right? Or a pricing schedule, or a schedule for your machines. Is that where the digital thread kind of like connects to this, to your other system?
I mean, you can, Graham, exactly. I mean, there's so many different use cases around leveraging the machine data digital thread. I mean, machine data is a component of that digital thread, right? So, it can tie into, you kind of have to look at it as you want to solve, you can't like boil the ocean. You need to think about, where this data can actually provide more immediate value. And if you have problems with shipping schedules, you need that data to help optimize your shipping schedule. That might be an area where you want to focus. And you'll need information from the machine. You'll need information from your accounting system, your customers, all together to be able to make those decisions. So, I think that's and there's hundreds of use cases, different use cases, not only in manufacturing but outside, as I represented in the presentation today.
Awesome. And so this is a great question. As somebody's read a lot about the digital thread, it's not always the technology, right, that prohibits manufacturers from enabling the digital thread, but how do companies overcome organizational challenges? You've been in that manufacturing world before, right? How do companies kind of overcome those challenges so they can deliver on the potential of systems like this?
Yeah, I mean, one of the challenges that we see is, like cloud technologies have been slower to be adopted in manufacturing versus other industries. And, the digital thread really does require the cloud and, the ability to share data from one system to another. That's an area that I see some pretty dramatic advancements over the last couple of years. And, both, all the way through the largest of enterprises, even in, aerospace defense, which might be one of the, I would say one of the later industries in manufacturing to adopt the cloud.
Cool. All right, we've got just a couple more. So, and we like to keep our webinars as short and to the point as possible. So, here's another one. I was wondering if there were strong use cases that we've come across for implementing mobile technology on the shop floor. Not fully related, but somewhat related to the digital thread.
Yeah, I mean, that's really like one of the things that we've done is we've built this. We built our applications to be completely mobile friendly, so you can use any type of device to access the data. And even just as a simple text message, but also using the application. You might be kind of referring to some of them. It's like Wi-Fi and cellular, and having access to this data through the cloud really does enable mobile technology. So if you're sitting at home and you want access to your data, because we leverage the cloud, that's easy to do. So a lot of our customers actually experience machine metrics mostly through their phone, and that's something that we're seeing more and more.
Okay, so for the delivery, essentially the delivery mechanisms like the applications, right? You can see how that can make the data useful by leveraging mobile technology, but also even in connectivity options, right? Like whether you're using.
Yeah, I mean, I guess further on that, specific to machine metrics and a lot of the modern applications that are being built now, they are web-based and they're built to support mobile. So, we don't have to build a separate iPhone app and an Android app and then a desktop app. We build one web application that's called responsive, so that it behaves differently when you're on your phone. The user interface changes, but it's optimized for that experience. So our customers are able to benefit whether they're using a mobile device or a big screen TV.
Awesome. This is a great. I was thinking about slowing us down, but this is just a great question. I've got to answer it because I think this is what a lot of people are wondering, right? How does AI, right, fit into the digital thread equation? And is that common, like today? Is that actually enabled?
So AI is overused. So that's the one thing I'd say. But what you do, to have a true sense of understanding and predicting problems and uncovering opportunities, the more data that you have, the more of a chance that your AI or machine learning algorithm will actually give you results. So if your domain is really small, it's around, say, inside the machine, you might not need that external data. But if you start to try to predict use cases that involve many other processes, you absolutely need that data to train machine learning algorithms. A lot of these algorithms are very unique and custom, and that's actually a lot of the, most of the expense and time that goes into building out these algorithms is really collecting this data. So if this digital thread was, really, where we want to see it in the future, where everything's connected, you're going to see a lot more around AI and machine learning and predictability across, many different domains.
Awesome. Awesome. Well, unless anybody has any other questions, I think this is a great time to wrap up. I just wanted to thank Bill for doing such a great job today. We've got more questions coming in. As Bill, you got time for one more, and then we'll wrap this up?
Absolutely.
All right, cool. So, so Doug asks, so what about products designed in a more analog world? It would seem like products would need to be designed this way from start to reap the benefits. Is there a way to digitize things retroactively?
Yeah, I mean, we do this all the time. And you're not going to get quite as much data off of, say, an analog or an older machine, but fortunately, we have access to all of these sensors that we can deploy pretty easily to be able to replicate, in this case, maybe a more modern piece of equipment that already has these sensors. I mean, the analog world is essentially the physical world, right? We convert it to digital. So there isn't much of a difference of converting an older piece of equipment to digital using sensors as there is new equipment. It's just that it takes more time to install this hardware.
Awesome.
And there's a cost benefit to this, right? Sometimes it's easier just to buy a new piece of equipment that already has this capability as opposed to retroactively digitizing an older piece of equipment.
Yeah, as we all know, right? And many of us have, very old assets that still work quite well, right? So even in the CNC world, there are still older, more analog devices that need connection, right? It's something that we found. So I think that your answer is really really interesting. Doug wants to know if you could do that for a fighter jet that took 20 seconds.
Well, I can tell you that fighter jet has millions of sensors on it, so I wouldn't want to touch that. I can only imagine the little bit of that I put into this fighter jet. I have no idea whether that's still in operation today.
Yeah, and I would also note that I think this is this is really the vertical platform, right? Discussion, right? Where the manufacturing shop or the connectivity, the digital thread that exists there, how do you connect, right? How do you get to that fighter jet? Well, you need to weave together best in breed systems, right? Not one system would be able to cover that whole process, and that's kind of the beauty of the digital thread is you can connect something like machine metrics to another system that manages data that comes off the fighter jet, and you can actually start extrapolating interesting data across the entire ecosystem. So that's definitely a really cool idea. Well, okay, well, I think we're going to wrap things up now. Just want to thank you all so much for joining us. We will be having a number of awesome events next month, which we'll be sure to email you all about. Again, we will be also sending out a recording as soon as possible once it becomes available. But we just want to thank Bill for his great presentation. Thank you all for joining us, and we look forward to talking to you all soon. Have a nice day, everyone.
All right, thank you, everyone. Bye-bye.